So let's go back now to our linear insertion with Sentinel. Let us see. First, let us try to see how we could make a sorting thing out of this thing. And so could we make component or 2 or 3 out of that which will sort and which will be useful? When will it be useful? Okay, let me, for example, just go ahead. Let's assume that we don't cancel the class and we survive. Eventually, we'll have to study a very important algorithm called quicksort. And long time ago, the person who invented quicksort, Tony Hoare, observed that quicksort becomes inefficient toward the end of recursion when you start doing partitions of very small things. And he suggested that what you need to do is to run insertion sort down there. And originally people thought what we will do, we'll go down recursively and call insertion sort every time on a small subbranch. But then, actually the same Tony Hoare observed that you really don't need to call insertion sort many times. You could just stop the recursion when quicksort sorts things up to a certain size, and then at the end run one pass of insertion sort over the whole thing. Because things are already, remember we talked about it, that when we know that things are almost where they should be, you could use insertion sort. But quicksort could guarantee that. It will do things up to a certain limit, sort of partitioning, and then stop. So eventually, everybody will be within certain threshold of its final destination. Now, what I don't know whether other people observed it, but at least what I observed a long time ago is the interesting fact that when we do that, what we have is the following interesting situation. Let's assume that we're sorting million elements. Then, after we're done with our quicksort pass, what we know that there are between first element and the threshold, let's assume our threshold is 16. Not necessarily 16, but somewhere within this range, will be all partitioned here. And then there will be guys here. So these guys are natural sentinels for all these guys. So what you could do, you could use the insertion sort which we just wrote for the little one. Because then we need to care about not hitting, not passing the boundary. But what we could do here, we could just run it and rely that there are sentinels past it. Right? We might, so we could do a very simple thing. We could have, now we just need to come up with a good name. We have insertion sort. Imagine that we do one thing here. Instead of linear insert, we call linear insert with Sentinel. That would be a perfectly good function to call for this thing. Right? Except we need to find a name for it. Could we find a name for it?
What is it? Insertion sort with Sentinel?
That's a perfectly good name for it. Yes.
It is insertion sort. Could we write?
Yes. it should appear momentarily. And what's its code? You should have copied the code.
Yes.
But it requires one modification. This is good. It's a scheme that we sort of somehow, somewhere before us, there is somebody who will stop us. Right? The sad fact, of course, is that it's not always the case. Could we still use Sentinel?
If we add a condition and if we swap current with the first.
All the time. That is a very important thing. You do not want, it's possible to create Sentinel once.
If current is, if R current first, then we replace them.
Where? In insertion sort? Or where do you want to do that?
You can find them in as well.
Okay. Which leads us, let us think about it just a little bit. Because this, by the way, leads us to another classical sort. Fairly slow, but since it's classical and will take few lines to write, let us discover it. There is a sort of ancient sort called selection sort. What's the idea of selection sort? You find the min, put it in the first place. You find the min of the remaining, put it in the first place, and so on. Could we write it?
It's expensive.
Yes, it is.
Should we write the sort, the selection sort, or should we just find the minimum?
I would recommend that we write selection sort. It would be good.
We put a precondition on insertion sort with Sentinel.
Yes, we should put the precondition. Thank you. Thank you. We might not be easy to write it, but we could use this wonderful language called English.
Predecessor of the sort of the first should exist. So the first, it should be valid.
There is a valid Sentinel.
There is a Sentinel at or before first. All right? So we're relying on the fact that somebody will stop us. Or sort of another way of putting it, that we're relying on the fact that either first is minimum or previous to first is less or equal to minimum. Maybe we could write that.
There's it's stronger than, there could be one in far beyond first, but.
It could be, but then you get an interesting thing. You move some of the elements, sort will stop looking like sort. Because you sort of expect sort to do a permutation of the range. If your condition is true, what might happen is that the elements from before first will get into that range, if you see what I mean. So it might be satisfactory in some situations, but I think that this is the common case. And there you basically are sure that, no. But another thing, it's just maybe sometimes you want to make a precondition fuzzy. and maybe then Nick is correct.
I don't like I like the one you said with it's either first or the predecessor first, even if it might work.
Again, we have to be very careful because sometimes in practice, we will see that sort of the reality of life that you might say, well, yeah, but it's all right because I'm sorting this big thing. And if there is some diffusion of elements on the boundary, it might not matter because I'm in reality sorting the big thing, not the small thing. So it's a delicate point. It's a delicate point. Right? So, okay, let's write something. Vitaly.
First, either the first should be the smallest element in the range, or the predecessor first.
Or smaller than smallest. These are slightly different. The predecessor could be smaller than smallest. That's perfectly all right. You like the other one?
Yeah, the hand wavy one.
Okay. Say hand wavy. Well, not the same.
That's what you said. Valid Sentinel exists at first or before.
Well, then are you going to write the postcondition that expresses what happens for anything that passes?
Yeah, like the observe that the elements could disappear. Yes.
Should we define a valid sentinel in this case?
I don't like this because of the word sentinel. You have to understand what's on it. Try to just say what you mean.
Well, Sentinel we could define it. Then we could replace it. Sentinel is an element which is sort of for sure will be less or equal than the minimum.
Because I think it's back to where we were.
No. The issue is where should it be? That's what Hernan is discussing.
Right. Of the current range.
Of the current range. I would
Before it's
split
not
it.
precise, it can be further than predecessor.
Yes, that's why here. This is why.
Then we sort outside our range.
Yes, and we will sort outside of our range, which might be acceptable. This is again, guys. This is the thing which you need to think. We're trying to come with useful components. What is the most common case for use of what we're writing? This is, by the way, literally just this. And here, since we do not know where the exact threshold is, because quicksort does things probabilistically, it's sort of, it's not greater than 16. So we know that somewhere between first and 16 elements before first, there would be a sentinel. Right? It's a very tricky thing, but we have to explain what we do, and that's what the code actually does because we don't need to create a sentinel. We know that quicksort created a sentinel someplace. We just don't exactly know where. Right? And we don't care. We know that. Yes?
The issue that I have with this definition or this precondition is that we don't actually sort what's before first. We just potentially insert things before first.
Well, which
We're not guaranteeing that it's actually going to end up sorted.
in this case we do. We first sort this with insert. with regular insertion sort. And then run.
If we do that, then we don't need this. Then we don't need this.
Well, we absolutely do need this because we're writing precondition for this component.
Right, what I'm saying is that we don't need to allow for the element to go before first.
What do you mean we do not? How else would it work?
Or rather, I would rather the precondition be that first is the minimum element, rather than being able to go before it.
Yeah, but you do not guarantee it here. I mean, this is all very nice, except it doesn't work in practice.
Something in that second range could actually get sorted down into that first.
Yes, absolutely. Yes, but guys, this is a very, very important point. We are not here to impose some theoretical conditions on algorithms. We are here to take existing efficient algorithms and find how to express. I mean, otherwise you will get very quickly, we'll see in a second, to a point, and we cannot do this, and we cannot do this, and most of the code will become, okay, I'm speaking facetiously, but you will move to Python. Right? Because that's the only place where you don't have pointers anymore, you guarantee safety. We'll be talking about it very shortly. Because however we write this precondition, as we shall see, there will be programmers, real programmers, who would use it in some terrible ways. Just give me a second. So this is, again, we have to write whatever we write to enable this code to work. That's what I'm trying to say.
I agree. I guess my point is I don't see currently why this precondition is necessary. It's looser than is necessary.
Yes, because let us look and see how it works. Again, I repeat, you run, what?
I'm willing to see how it works out.
Okay, okay. So let us.
I'm wondering if we just change the name, since it's not always going to sort. Maybe we just say, maybe sort.
But it's always going to sort. It will sort more. Yes, that's its intent. The intent, the literal intent, that you already have sorted guys here. And one of the sorted guys will serve as a sentinel. Not necessarily the guy right before. What? Okay. Let me show you. It could be 1, 3, 5, followed by 2, 11, 17. This is first range from 1 to up to, but not including 2. Right? 5 is not a sentinel. 1 is.
And so what are you claiming is the postcondition after we run this?
That this is sorted.
But the range you asked to be sorted is sorted.
Or it is going to be.
Because you start with 3 and you sort
3 in. That's the whole point. That must be the postcondition.
So I think there's when you have a function named sort, there's an implicit assumption that typically it's the items that were in the range are now sorted in this exact same set.
Yes, I pointed it to you just a minute ago. But what I'm saying, in practice, we need this function.
It's just by calling it sort.
Change the name. Change the name. Again, with Sentinel,
You'll get a sorted range of some elements, that you might not have known were there,
but basically what you do, you rely on the fact that these guys will be sort of, if necessary, inserted in.
Are you also relying on the 135?
Being sorted. Yeah. Yes.
So the difficulty here is that we will sort the collection, not from first, but from the Sentinel.
Suffix sort, suffix insertion sort, sort suffix. Yes?
It's just
So, why wouldn't you just give it the,
Because you don't know.
you could give it the entire range, and then you would be guaranteed that the Sentinel was within this group.
No, if you give it the entire range,
If you insert the first 16 elements, and then you
you will be resorting these guys. You don't want to do that.
well, you won't be resorting those guys.
You would. I mean, you are not going to change their position. You're going to be doing work. Yes, I do not want to do unnecessary work. Right? Again, guys, the dominant thing is that we're talking about how to write efficient code, which means, remember, it's like Knuth comes and says, I could create a Sentinel. We have to take him seriously. Any so-called software engineering consideration vis-a-vis Knuth is bogus. Knuth dominates. He's just, well, by Knuth I mean efficient algorithms. That's what Knuth does. Yes?
So I don't know exactly what we're getting at with quicksort. So my understanding is quicksort is breaking down into partitions.
Yes.
And within a partition, because we have not finished it yet, we're stopping.
Yes?
Within the partition, we aren't guaranteed that things are sorted.
They're not.
And we are also not guaranteed that the very lowest thing of this partition is in fact higher than the very highest thing of this partition.
No. Within partition, they're scrambled. But what we know that everybody from the previous partition is less than anybody from the following partition. That we do know.
So we wouldn't have two there.
Then you couldn't
right?
have two in the second partition there.
The lowest that could be there would be a 5.
The reason why this
No, it could, because I'm not saying this is the real partition. I have absolutely no idea where the real partitions are. Yes, quicksort stopped here. That's the but I don't know that. I know that quicksort stopped within some threshold.
But you know there'll be a partition boundary within the first.
Yes. Yes, that's what I'm talking about. It's not, I do not know. You can say, why don't you store it? Because that requires overhead within the, right? And I don't need to. Again, guys, the problem is that I have code which works. I mean, or Knut has code, or whatever. There is code which works. We have to explain it, not trying to sort of say, well, but that's, that's unsafe. Yeah, it is perfectly safe because we know that there's somewhere here there is a Sentinel.
So could we just, for any range that we want to sort, could we just say, okay, take that range, add to that range the...
Let us first finish that. Yes, we can, and we will get to that. I mean, guys, we have to, otherwise we'll get to, I'm not, this is correct, and we will get, it's a good question, we'll get to that. This is why we started doing selection sort. But then, so let us try it. We still did not write it quite correctly, because what maybe we'll literally want to say what the situation is. What is the situation? That there is some prefix, sorted prefix, which contains a Sentinel.
We're extending the sorted range.
We're extending the sorted range because we know that if we do this, you understand the situation, I mean, right? So, but now we need to write the precondition, okay? Again, who wants? Should I let Nick? Give it to Nick. He's jumping there, so let him. You could actually change the name.
Yeah. So I like the term extend that Hernan just said. So like
Sort, but you don't like suffix?
suffix is okay, but I mean what the extend means that it implies that there's a prefix that's sorted, like extend. But I don't.
Sort, extend with insertion, sort, extend? Extending. We already lost that, sadly enough, introducing insertion sort, which probably, this is the interesting question. Should we stop calling merge sort and start calling it sort? It's very hard. You know, there are certain terms which are built in. Everybody already knows what insertion sort is. If you see what I mean, it's not, I mean, you know, you could Google insertion sort and you will find it. If you Google, you want to use names which Google finds, if you like. I mean, for this one, there is no specific, I mean, it's probably insertion sort with some words addition, because it is insertion sort.
Insertion sort suffix.
Suffix? Let's call it suffix. Then we have to explain carefully.
I guess so. Precondition. So does it have to be sorted up to first?
Yes, it has to. Otherwise, there will be who knows what. It's sorted after, before, first, and there is a sentinel.
So just say a valid range before first contains a sentinel value?
But the sentinel value could include first.
Okay. I see.
Okay. So there is a range from before someplace up and including first. Well, it's hard. Here it has to be sorted, but we allow the sentinel be here just in case. It's a fun.
So you could do it as an or you could say a valid range before first. No, a valid range before first contains a sentinel value, or first is a sentinel, the lowest in the range from first to last.
I think that would work.
Okay.
I think that would work.
So, and I'm not going to say lowest. So a valid range before first
Is not less. I mean,
is sorted with respect to R. Is that fair to say?
yes.
Sorted with respect to R.
And contains a sentinel.
And contains a sentinel.
This is first. We might literally write first, second.
First, second. First precondition, second.
First condition, second condition, or second. It's either first condition or second condition. Whatever. I shut up.
I guess the first.
Well, first is a sentence.
First is the sentinel. Our first is the sentinel value.
Now, just very quickly, could you dictate selection sort?
Selection sort. Okay. Template. So just take the.
Do we need bidirectional iterator?
No.
No.
So okay, selection sort. So just forward iterator. While first not equal to last, we'll do the loop and then we'll see.
Yeah. It's called minimum element.
Minimum element. First.
Except I would replace it with, as we did before, yeah.
All right, current.
Actually,
So current
no,
is-
we don't need that. We don't need that. We don't need cutoff.
First million for time.
We just don't need cutoff.
So
Will be
minimum
great.
element first, comma last. We're gonna, and then standard
Probably R.
R. So we need to store that in a value, right? So that's a I, well,
What do you want to do with it?
Swap it.
So swap it.
swap it first. So standard swap first.
I would not swap it later.
Oh,
I
star,
know.
star first.
It will work too.
And, yeah.
Is that stable?
No, it's not.
Okay.
Okay? We took it. 1 second. First we need
And we need to increment first.
and then we need to transfer. And now let us copy this piece of code, and Nick will tell us how to do it stably. And it was going to be called, anybody wants to suggest a name?
Stable selection is right.
Yes. So what do we need? I mean, which part still works? No, finding minimum element part. So why it's not stable?
Well, you're just taking your current element, whatever it is, and just throwing it somewhere.
You're jumping over. The moment you jump over, you could jump over guys equal to you. And that's that. It will never, I mean, the information is lost. Right? So how to prevent it?
You could find where the
No. Yes. Specifically, what kind of rotates? Come on, guys. I mean, you have to remember things we did last time. Yes, you were here for that one. Yes, you were. You might have been asleep or after coming from a hospital, but you were here. It was called. Thank you, Bert. Yes. We spent a long time discussing these two algorithms, remember? So that's what we want to do. We want to rotate right by 1. Except we need to figure out what is the range which we are rotating. Is it? Okay, let us see. We are taking 1, 2, 3. Pardon me. 3, 2, 1. We're sorting, yes? And we found the minimum happens to be 1. What do we want to rotate? Do we want to rotate from here to here? Right by 1, yes? But that will give us, believe it or not, 2, 3, 1. Semi-open ranges, guys. Now you have to, not last, but this guy you need to,
minimum.
to do +1 or plus.
So we have to pull out that value.
No, you don't need to.
I just rotate right by 1.
No. We don't need stars anymore.
Yeah.
So replace star with,
No star. Right.
but we need to move it. How do you move by 1? Guys, how do you move a pointer by 1? Plus moves it by 1. Perfectly all right.
Replace swap with rotate right by 1.
Yeah. And now replace swap with rotate right by 1.
And drop the star.
Yeah. Okay, so now, why am I doing all of that? Well, selection sort is not particularly useful. By the way, when it's useful, when people really consider doing it. There's only one case.
Top end sort? No.
It's a rare and basically only theoretical case. Theoretical case is swap is very, very, very expensive, or at least for this sort. The non-stable selection sort. And comparison is dirt cheap. I mean, you're sorting things, it's very quickly to look at them, but then these are like buildings you need to carry. So swap is very expensive. And that selection sort, God will look at it, it does absolutely amazing amount of swap, just n minus 1. Always. Merge sort, quick sort, they do, roughly speaking, n log n number of swap moves or whatever. And here we're getting to linear. Is it practically important? No. Let me tell you, not over my long and adventuresome life, writing algorithms in all kinds of contexts. Not once I needed selection sort. Why do I talk about selection sort now? Yes, because what we need is either this or that line to make our insertion sort work, depending whether we want stable or unstable insertion sort, linear insertion sort with Sentinel. Right? That is, we could create a Sentinel in a stable or unstable manner. And again, for stable you will pay more because you will have to do rotate. It's still a linear operation, relatively fast compared with sort of what you're going to do. But again, measurements will have to be done. Okay? Anybody wants to? Do you want to continue? Continue. Whether you want or not.
We want to do this insertion sort with Sentinel.
Yes?
Okay.
So you propose to call it insertion sort with Sentinel. Or do you propose to call it insertion sort?
Well, we had linear insertion sort. So now we're going to use the suffix version, right? Or we're not?
I don't know, guys. I'm talking to you. Naming is extremely hard. In some sense, one of the lessons which I'm trying to teach you is that naming components is a very, very important thing, right? We sort of surrounded. People say, oh, I'll build this component and call it Vasco da Gama, well, or Cabral, whatever. They, this is wrong. The component has to be named so that people could actually understand what I mean. Right? It's forever, and it will help people. So naming is very hard. So again, part of the thing which I think we as a community, broader than this, have to do is to have this discussion of nomenclature. How do we call things? What do we call? And you say, well, respectable sciences do not do no. This is the opposite. Respectable sciences spend most of their time discussing nomenclature, whether it's chemists, physicists. They know what to call things. It's only in computer science. I remember, I have to tell you the story, told to me by Sean Parent, the guy, that when STL was introduced, people at Apple decided to try it. And they tried it and found it absolutely unacceptable because we replaced our list with STL list and everything became extremely slow. You see, the problem is that their list was what STL calls a vector. And they replaced it. They didn't realize that linked lists are linked lists. Right? And things sort of worked, but, maybe slowly. Right, if only that. Right, but in any case, so having standard names is very important. Let us try.
this is, we want to do insertion sort with Sentinel, but does the fact that we're doing it with Sentinel matter? Do we need to put that in the name? I don't think so. We just,
So maybe then we need to rename the other one and call it insertion sort traditional. Or classic.
I like, yeah, insertion sort classic.
Classic. The problem is that we will see. Let us write the new one. And there, by the way, there are two versions of new one. Right? Stable. So insertion sort itself is stable. The way of creating Sentinel could be stable or unstable.
So let's start with the stable version.
Let's start. Did we rename the other one?
We didn't. We can rename. I mean, is life going to be easier if we don't? Is there some name that you want it to be? We can.
No, which we cannot use the same name twice. That does not work.
I don't know whether you had some code calling into it already, but so insertion.
Oh, we do now, but we will. The old insertion sort we just tested, but let's rename it.
Let's call it insertion sort classic.
Classic, yes.
No,
it's not this. It's the other
The
one.
original insertion sort.
Not that one. This one. Whatever that is.
That one.
Yeah, that one. Classic.
Okay. So then we want to copy this.
We either copy this. Let's go back and put it. We need to put it logically after this all the Sentinel work.
Okay, so this is just going to be now insertion sort. And
So we could write, by the way, what we could do, this is why I like, if we write this also, the precondition with successor, it will be simplify life a little bit. Because whichever sort we know that if first is equal last, or if first is equal successor of last, we could return. And then I want to say / create a Sentinel. I'm not into comments, but here I would recommend it.
So, can we just do that right here then before? We have to increment it anyways.
But then you probably should say comment. You could do the other one, but it's
so yeah, well, let's copy the line from the selection sort. Select from selection sort stable. There.
Stable?
Yeah. Right?
you want to start with stable. That's an interesting thing. What is going to be the default? The one, are we going to have insertion sort and insertion sort stable, or are we going to have insertion sort unstable?
No, insertion sort and insertion sort stable. So
Okay, let's argue.
I think insertion sort should be stable. Just the algorithm is naturally stable. If you write an unstable one, you're going to confuse something. Trip them up.
Okay, but why then we have sort and stable sort? No. I'm listening to your argument. It's a very good argument. The one non-stable one is faster. But Bert is correct in the following sense. He says there is an expectation of stability when people call insertion sort. So, it's a solid, again, we're not working in vacuum. We're working against the sort of tradition of programmers. And programmers expect, for example, while we have sort and stable sort, I think it would be very unnatural to have merge sort and stable merge sort. If you see what I mean. People know that merge sort is stable. So probably the correct thing in this case, for sure, would be to have merge sort, and when Ryan comes with much faster version of merge sort, which is not stable, call it merge sort unstable, saying we're sacrificing stability, but we're gaining performance. Yes? So I'm actually buying your argument. Right? Because expectation, there is an expectation of stability. Actually, nowadays there is no expectation of anything, but you know, whatever. I think Bert's argument is good.
So let's just grab that line, rotate right by 1. Line 90, and go back down to insertion sort. So, yeah, we've advanced first. Do we put that, I guess, could we put that right after?
Well, you have to figure out where you're looking. It's from first to last. It's not to current. You're creating Sentinel for all the guys.
So should that be the second line of the function then?
Second line of the function? Should it? When you have a singleton, do you need to do anything at all? No. So rotate last by 1. So that creates, and I would write on line 138 / creating Sentinel, colon.
And then replace the call for linear insert to insert with Sentinel.
Insertion sort in Sentinel?
No, we're just going to insert. Wait, is that?
No. No. We already have the guy.
Oh, I see. So insertion sort with Sentinel.
Oh, insert a double loop.
Drop the loop.
But is it with Sentinel? No, it's insertion sort suffix. You guys have to stick. You gave me a hard time.
Yes, okay. So insertion sort suffix with Sentinel, and then we can go from current to last, right? And
To
R.
last. First is already in place. We don't have to. But it could, think about it. Here it could literally sort of, it stops at first. But it doesn't, whatever. It's, you know. Okay, all right. So now we could, with cut and paste, create another wonderful thing. It's called insertion sort unstable. And then I'll have to tell you a remarkable story, which will demoralize you completely.
The only thing that's unstable about it is the first swap, right?
Yes?
Other than that, it's stable.
Yes?
So it's almost stable.
Yes.
99% stable.
Just like our code.
What? It's possible.
If you've got just the 2 elements and it's larger, smaller, you're going to drop out of the.
No, I'm the first. Rotate 1 by 1, or
Before that, if you have your first, if you have only 1 element, you return.
no. If I have no elements, I return.
Oh, no elements. Okay, 1. Okay, there. Okay, I'm sorry.
No, it's this. Everybody makes this mistake.
So it's the swap.
So this is the swap.
Swap.
You can, yeah.
And to do swap, you have to put stars.
Yeah.
Now, just to end this lecture on a good note. So, is it good? Is it solid code? What do you think? Assuming that we get rid of fallback. Looks all right. Now, about 7 years ago, there was a big commotion at there's this advertising company you might have heard in Mountain View called Google. So somebody decided at Google, they have bright young things, and one of the bright young things decided that he wants to randomly shuffle a vector. It's a reasonable thing. Even at Google, you might occasionally randomly shuffle things. So he decided that the correct way of doing that is the following. You implement a comparison function which throws a coin randomly, sort of generates true, false randomly, and then take std sort and pass this function to it, because it will obviously create a randomly shuffled thing. And lo and behold, to everybody's amazement, it caused segmentation fault. Google came down or whatever, I forget. There was some dreadful thing because it actually worked and then it didn't work. It was this irreproducible bug. And there were messages throughout Google saying STL is totally broken. Obviously, it brings Google down. I mean, how else? So, of course, one could argue that he shouldn't be doing what he was doing. Let's see, there are a bunch of arguments. What's the first argument? You're too technical. Yes. We will get to that. But there is even simpler argument for those, of course, some people would say, well, there is an algorithm in STL called a random shuffle. Why not use that? But, they don't, nobody ever looks at what algorithms STL has, so that's not something they would do at Google. Then somebody more advanced would say, well, even if it worked, it wouldn't be a uniform random shuffle. It is going to be absolutely screwed up random shuffle. But that requires some knowledge of probability theory and the existence of Knuth and things like that. These people don't read. I mean, they hire only the brightest people. And brightest people do not need to read. So, no. And then somebody, my dear friend who was on sabbatical at Google, ventured to post what Bert just said, that throwing a coin does not give you weak streak ordering, or actually no ordering whatsoever, because one day it gives you one thing, another thing, another, and it's just mess altogether. And of course, STL sort, as I probably mentioned, is quick sort. And at the end, it uses this. Therefore, it uses Sentinel. And every so often, Sentinel with this thing is no longer a Sentinel. It was Sentinel today, it's not Sentinel tomorrow, because it's all random. So there was apparently violent discussion. And my friend's arguments.
That's why they put in the "Are you feeling lucky?"
Yeah, feeling lucky, yes. So this is sort of, but my friend tried to defend my order. Well, he is not just my friend, but the person with whom I have been working on generic programming for like 30 years. His name is Dave Master. Some of you might have heard of him. So he tried to explain, but it was like, no, people should work whatever I pass to them. Right? So it's basically apparently an expectation of a modern programmer that you don't have to satisfy any precondition. That things should do something and never cause a segmentation fault. And it is a tricky thing, which sort of, nowadays, I wonder, sort of, what should we do when we build components? Should we assume that we build them the fastest way and carefully specify preconditions? Or should we build idiot-proof or Google quality components? This is a difficult question. I do not know the answer.
I think there's, When you make idiot-proof components, they're harder to read too because they're filled with all sorts of checks and.
I know. No, I mean, but that creates this unbelievable sort of situation. By the way, if you Google, I don't know whether you could find it now, but for a while, there were a bunch of postings in open internet from a bunch of Google guys basically saying, well, do not use STD sort because it requires weak streak ordering. And that is another sort of marvelous thing. I thought that, people will say, oh, total ordering should be the thing. So the fact that I was using weak streak ordering, which is provably the weakest possible requirement for sorting, I thought it was good. But they turned it and said, no, since it requires weak streak ordering, do not use it. Use stable sort. And you say, well, it's only people there in Mountain View. No. I've seen, even in a local code base, places where people use stable sort instead of sort, even while there's absolutely no need for stability. Why? Because they read these discussions. Because things. So what could we do? These actually will sort of, it's an interesting thing, because what we will be observing is that there are very often algorithmic techniques which depend on preconditions, like this Sentinel thing. Could we use them? So I sort of, okay. So let me tell you what I plan to do. I sort of spend a lot of time on insertion sort, merge sort. What I was thinking about, but before I announce it, I wanted to discuss it small class. What I thought maybe to do next week, instead of having our usual conversation, to have a little competition. Programs nowadays are very much into competitions. So we will look who could implement the fastest stable sort. We already have all the algorithmic knowledge we need to have. We even have most of the code you could possibly use. So do you think it's a good idea? Is it? You want it? Okay. So get prepared. Bring your laptops. By the way, you could practice all you want between now and then. I'm not saying you have to sort of come fresh. No, don't come fresh. I mean, implement it ahead of time and then win. Right? But the idea is to use all the techniques. We have the idea list. And you should look and think about, sort of, do we eliminate recursion? What is the threshold for switching sorts? Which version of insertion sort? And we have many. Do we need to, by the way, do we need to go and re-implement? Let me mention just one more idea. Could we go to the file called ideas? Because basically, ideas. Recursion is right, very good. But yeah, so there is this thing. We already have adaptive part. But for non-adaptive thing, we still use merge, STD merge. Could we write faster merge than STD merge? Just could we write better merge than STD merge? That's oh, yeah. Because we spent some time talking about merge when we were doing merge for linked lists, and we discovered this evil instruction called go to, and things like that. Maybe we could use these techniques. I'm not going to tell you what to do. This is, we already discussed all of that. Again, it doesn't have to be mano a mano. If you want to team with someone, it's perfectly all right. If you want to be mano a mano, that's fine too. It's whichever way. Right? No, there is no price. And there probably will be no winner. There might be, I mean, you know, I'm not aiming of one, if there are like two people who are coming sort of with one person wins on double, another wins on string. Look, it's what I hope that it will let you discuss. I just want to switch from me guiding it, at least for 2 hours, to I'm just an observer. Or I could answer questions like C++ questions. So everybody? Wow, talking phones. It just talks. New phone. Okay, so let us see how it goes. And you could read Knuth, you could read the whatever. No, but don't you want to win? All is fair in love and war, you know. Sort of cheat. Look at all this Telcon for like, yeah. I mean, you know, this is a little too much, but I'm not going to object. I mean, whichever way. Yeah, you think it's all right? Then, okay, after that, let me just one more second. There are, you know who Brian is. He runs the place. So we were talking, and he thought that maybe we should restart the course, because he feels that maybe there are some people who feel that they're too far behind and not attending. I do not know whether it's true, but Hernan actually knows at least one person like that. More than one? More than one. So there are at least 2 people that knows like that. So I need to figure out. So I want to finish, because nobody could really, for example, an outsider cannot really do this stable sort now. I mean, because it just can, but it requires work. So, but yes, you're right. But so I need to think about that. So I'll talk to you more at the end of the class next week, yes? By the way, Paul, you're welcome to join the competition. You know, it would be nice if some old guy beats all the youngsters, you know. All right? There are cookies.